Hello all, this is Priyadashini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to continue with the next lecture series, that is GRU, Gated Recurrent Unit. Let's understand the problem in the sequence data sets. So when you have to process the sentence word by word, for example, here you consider I did not like this movie. So when you feed this into the model, your recurrent neural network model, this has to predict negative sentiment because here you have not, I did not. So not is the most important word here. So when you take traditional RNNs, as you move forward, the early words get lose or it may lose importance due to the vanishing gradient problem. So the most important word here is not. This not should not be forgotten by the recurrent neural network model. If the network forgets not, it may predict positive sentiment. It may give the wrong assumption. So if not fits, your model thinks it as positive model. So for doing this type of problem, we have to go for the gated recurrent units or the LSTM. So we have seen what is LSTM. Now let's see what is GRU. GRU is widely used because it is even faster to train than that of LSTM. Let's understand the core challenge here. So the problem is when you feed the words like I did not like this movie. So here the word not becomes a major thing. So the network should not forget this word not. So the existing solution for avoiding this problem is long short-term memory. So here in this long short-term memory, the model will remember the word not and ignores the unnecessary words like this all. So it combines the contextual text properly. The same thing is the GRU also does. But what is the major core challenge in long short-term memory is it uses mainly three GRUs like forget gate, input gate, output gate. Forget gate, what does it do is it forgets the unimportant words. Input gates feed the important words that has to be remembered by the network, and then finally your output will be generated. So in LSTM we have three GRUs, so there are more number of parameters. When there are more number of parameters means there is more number of computation has to be taken over. So we need a simpler solution model. So that is why we were moving to GRU. Let's understand the working model of GRU. So GRU was first introduced in China by 2014. So in GRU, it uses only two gates. That is, one is reset gate, the other one is update gate. So reset gate and update gate are the only two parameters. There is no separate cell state, and the hidden state itself carries its memory. There is no need of the other hidden state. So here reset gate means that it will forget what are all the informations not needed in the past. Update gate represents the information. For example, in the previous case, not was the important word. So not will be updated in the cell state memory. So this is how our GRU works. So this is the architecture for your gated recurrent unit. So it consists of the hidden state, that is from the past information. Then you will have the input state. So here you have two gates. One is update gate and the other one is the reset gate. So after this information, it has been passed to the output gate, and then that output is being passed on to the next hidden state for further processing. So as we have discussed before, the GRU consists of mainly two gates, the update gate and the reset gate. So update gate is given by Z of t. So this gate decides how much information from the previous hidden state should be retained for the next time step. That is, if for T1, if it is not, then for T2, whether it has to be kept in the previous hidden state, it has to be retained or not should be determined by the update gate. Whereas the reset gate is given by R of t. This gate determines how much of the past hidden state should be forgotten. For example, the words like the are all not needed much. It is not given much importance. So the reset gate RT is given by the formula tan h of your weight, the weight of the reset gate multiplied by the hidden state of the previous state plus your input state. So this is the formula for the reset gate. So the reset gate determines how much of the previous hidden state, that is from ht minus 1, should be forgotten. So this is about the reset gate. So the next gate in GRU is update gate. So update gate controls how much of the new information should be updated in the present hidden state. So the formula is given by ZT. So update gate is denoted by Z of T. So ZT is equal to activation function of WZ, that is weight of this update gate, into multiplied by the hidden state of the previous time step plus the present input. So this is the formula to find the update gate. The next gate is the candidate hidden state. So this acts like a memory state. This is the potential new hidden state calculated based on the current input and the previous hidden state. So the formula is given here. H dash of t is the notation to define candidate hidden state. So hidden state ht, the next hidden state ht is given by this formula. So this is the weighted average of the previous hidden state ht minus 1 and the candidate hidden state h dash of t based on the updated gate. So this is about the working principle of GRU. Thank you.